This is chapter 3. It's about probability. This course is called Statistics, Introduction to Statistics or Elementary Statistics. So we don't study a lot of probability, but we need it as a tool to learn statistics. So I'm going to introduce you to the concept of probability. I already sent you a guided notebook, guys, for this chapter. If you downloaded it, that's great. You can take notes along with me. If you didn't, you can just pay attention to what I do, and once I finish, my notes for chapter 3, I will scan them and share them with you. But before I start this chapter, let me tell you what kind of algebra you need in order to be successful in this chapter. Very basic algebra. You need, first of all, skills review. Let me just do this. Skills review for this chapter, guys. You need to learn how to change the fractions to decimals, which should be very easy. So, for example, let's say you're doing some work in chapter 3 and you ended up with 7/38. You change it to a decimal, guys. I'm not asking you to do the work by hand. You can just do that on the calculator and turn it on. Here, 7 divided by 38. And you get 0.1842. Let's say he asks you to write the answer to 3 decimal places. To 3 decimal places, we need 3 decimals, so guys should be 0.184. That is how you change fractions to decimals. Now change decimals to percents. That's what you also need to know. So for example, guys, you ended up with this answer of a probability question, and you need to change it to a percent. To change a number to a percent, just multiply by 100% or move the decimal point 2 digits to the right. And if you guys move the decimal point 2 digits to the right, it's going to be 7.12, and don't forget to put the percent sign. Just a warning, guys, when you do your homework online, if he puts the percent sign for you, if it is right at the end of the answer, don't put the percent sign again because it's already placed for you. Otherwise, the system is going to mark it wrong. For example, if you have a percent sign already and you put this as an answer, the system will mark it wrong because you put the percent twice. So you just put, for example, 2.3 or 7.12, and then the percent is there. What else do we need to know in this chapter? Okay. I'm going to introduce this to you also. 7 with an exclamation mark. What does it mean in mathematics? Let me tell you what the exclamation mark means here. 7 with this symbol means you have to multiply 1 by 2, by 3, by 4, by 5, by 6, all the way to 7. This is called 7 factorial. So later, just in this chapter, if you are asked to do something like that, guys, this is what you have to do. Multiply 1 by 2, by 3, by 4, by 5, by 6, by 7. For example, 3 factorial means 1 times 2 times 3. 1 times 2 is 2 times 3, guys, is 6. 4 factorial means 1 times 2 times 3. You always have to start with 1, then go to the next one, then go to the next one until you get to the number. And that should be 24, and so on and so forth. The good news is you don't have to go do this by hand. Your calculator has a built-in feature that will compute this for us. So we're going to learn how to use the calculator to do this. What else do we need to do for chapter 3 as far as skills review? This is very much, just guys, the basic algebra that you know, and its most important thing is how to change fractions to decimals and how to change decimals to percents. So having said that, I'm going to begin with chapter 3 and tell you why we study probability. So I'm just going to project the first page. There you go. Okay. Let me tell you what probability is. When we don't know about something for sure, for certain, we don't have exact information, specific information, we're not certain about an event, we do a probability. For example, guys, let's say you toss a coin and you would win if you get a head. What is the probability that you would win? A coin has a head and a tail. So what do you think your chance of winning, guys?
1 out of 50?
You mean not 1 out of 50, 50%. That is correct. 1 out of 2, because you have heads and tails. So it's 50% or 1 out of 2. And now, guys, that comes into play why I asked you need to learn how to change, decimals or fractions to percent. You said 1 out of 2, which is correct. What about if we ask you to change this answer to a percent? So you just divide 1 out of 2 will be 0.50. And to change it to a percent, you just multiply by 100%. It will become a 50%. Okay. What about, guys, if we roll a die? I usually do this experiment in class on the first page, but since we're not face-to-face, we're not going to. So you have a 1, you have a 2, you have a 3, a 4, 5, 6. If you roll a die, what is the chance that you would roll a 6 face up? So you would win if you get a 6, guys. What would be your chance of winning?
1 out of 6?
1 out of 6. Why? Because the die has 6 faces. It has 1, 2, 3, 4, 5, 6. So it's 6 faces. It's 1 out of 6. Now, if he asks you to change 1 out of 6 to a decimal, you just divide 1 by 6, guys. If he asks you to change it to a percent, you just change it to a decimal, multiply by 100%. What's the chance? This is the chance of winning. What's your probability of losing? So you have 1 chance out of 6 chances to win. How many chances do you have to lose?
5.
5, yeah. Because if you get 6, you win. But if you get a 1 or 2 or 3 or 4 or 5, you're not going to win. So it's 5 out of 6. So I think, guys, with this introduction, you can feel what the definition of probability is going to be. It's going to be a number divided by another number, which I'm going to give you a definition in a little bit. Why do they do weather forecasting, guys? What you hear about the weather, when you want to know about the weather, they tell you it's a forecast. Forecast is because they're not sure, they're not certain. They just make a prediction. I mean, most of the time, their predictions are accurate. But I think, guys, you agree with me that there are times where they say there is 95% chance of rain and it doesn't rain because it's not 100%. When you are 100% sure of something, then it's going to happen no matter what. If I tell you I'm 100% certain, guys, that tomorrow is Tuesday, well, I know it is Tuesday tomorrow. But I cannot tell you I'm 100% sure that I can guarantee my internet access will be working throughout the day, just in my lesson. I cannot guarantee that. I can tell you based on my experience with it, probably 95% of the time it's going to work, or 99%, but I can't be 100% sure. When you are certain, you can say 100%. When you're not certain, you better go below the 100%. So, what is a probability? A probability experiment is an action or trial in which specific results are obtained. I gave you 2 examples about an experiment. We tossed a coin, a quarter. This is an action, this is a trial. Or we roll a die. This is another example of a trial, just to do a probability. What is an outcome? the result of a single trial in a probability experiment. For example, when you roll a die, you don't know, guys, what's gonna come up, face up. It could be 1, it could be 2, it could be 3, it could be 4, it could be 5, it could be 6. We said if you get 6, you win, but you don't know that it's going to be for sure 6. So the outcomes is anything that shows up. And for the die, the outcomes, guys, it could be a 1, a 2, a 3, a 4, a 5, or a 6. If we toss a quarter, what are the outcomes? Heads, head, or tail. Either you get a head face up or you get a tail face up. What is a sample space? The set of all possible outcomes of a probability experiment. So if you roll a die, guys, what could come up? You could see a 1, a 2, a 3, a 4, a 5, a 6. When you list all of them, this is called a sample space, and we list them usually like this. We put braces like that, and we put the 1, 2, 3, 4, 5, and 6. If I want to list all the outcomes when I toss a quarter, guys, what would they be? We're gonna toss a dime. Okay. The outcomes, guys, you either get head or tail. This is called the sample space. Okay, we're gonna do this together, guys. We're gonna toss 2 dimes at the same time. I'd like you to help me list all the outcomes that you could see. What could we get when we toss 2 dimes? Let's do it together.
Head, head, tail, tail.
Yeah, head, head, tail, tail. What else? There are 2 more.
Head, head.
We did it already.
Or
Head, tails, tails, head.
Yep. Head on the first coin and tail on the second, or tail head. How many outcomes, guys? Can you read it? Tell me how many altogether? 1, 2, 3, 4 outcomes. This is called the sample space. The sample space is the list of all the outcomes. If I toss the 2 dimes, I don't know if I'm going to get head, head, or tail, tail, or head, tail. I could get any one of them. The chance that I will get head, head, guys, is 25%. If you ask me how do I know it's 25%, because I have 4. So my chance is 1 out of 4. 1 out of 4 is 25%. The chance that I will get a tail, tail is 25%. The chance that I will get a head, tail is 25%. The chance that I will get a tail head is 25%. If you add all those percents, guys, you get 100%. Now we're going to do another experiment, and please participate with me here. We're going to do 2 events at the same time. We're going to toss a dime, roll a die. So we have the coin, and we have the die. Okay, I want to list all the outcomes. Okay, you guys can help me start. So we're doing it at the same time. You're doing, 2 actions at the same time. Tossing a dime and rolling a die. What are the outcomes? Help me list them, guys.
Heads 1.
Head and 1. Then,
Heads 2.
yep,
through 6. And then tails 1 through 6.
exactly. I couldn't agree more. This is the answer. You have 12 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You have 12 outcomes. Now, you would win if you get a head and a 6, for example, what's your chance of winning? It's 1 out of 12, guys, because there's only one head 6 out of the 12 outcomes. So your chance of winning will be 1 out of 12. But these are the outcomes. If you roll randomly, you're not doing, just anything that is biased or anything. You're just rolling a die and tossing a dime. These are the outcomes. You notice that we got 12 of them. I'm going to show you how you can figure out how many outcomes are there without listing them, because as you can notice, to list them, it takes, a little bit of work. So let me show you that nice, that theorem that will help us figure out how many altogether without even listing them. How many possible outcomes do you have on a coin, guys, on a dime? 2. You agree? It's either head or tail. How many possible outcomes are there when you roll a die?
6.
6. Why don't you guys multiply 2 by 6? What do you get?
12.
And that's the answer. That's the number of outcomes. I'm going to show you that it works right here. You toss 2 dimes. You have 1 dime and another one. How many possible outcomes are there on the first dime? 2. How many possible outcomes are there in the second dime? 2. If you multiply 2 by 2, guys, what do you get? 4. And look, 1, 2, 3, 4. Okay. Let's make it more fun now. We're going to put 2 dice. Roll 2 dice. Let's say this is a black one and that's a red one. Okay. If you roll 2 dice, guys, how many outcomes are there? Total number of outcomes. Who can tell me?
36 total.
36.
I agree. Because the first die has a 6, and this one has a 6, and 6 times 6 is 36. That is correct. You don't have to list them. But let's say, guys, we need to list them. I'm going to just start listing them. Can you help me, guys? You put
1, 1, 2,
Yeah.
1, 3, all the way through 6, and then 2, 1, 2, 2, 2, 3.
Exactly. 2, 1, 2, 2, 2, 3, and so on and so forth. And then finally 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, and 6, 6. See, if I list them, I get 36, but I don't need to list them. I know that there are 36 of them. This is the total number of outcomes. Okay, let me, so these are examples, guys, about this is called the sample space. When you list all the outcomes, you are doing the sample space. What is an event in probability? An event consists of one or more outcomes, and it is a subset of the sample space. And I'm going to give you an example. You roll a die. You would win if you get a 3. So what's your event? Your event is the 3. It has only a 3 in it, and your chance of winning, just this event is 1 out of 6. Here's another example. Toss 2 dimes. My event is getting 2 heads. Okay. What's the chance, guys, of getting 2 heads? If you list all the outcomes, which we did earlier, you get head, 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 tail, tail, head, tail, tail. Okay, so getting 2 heads. This is the only way I can get 2 heads right here, H, H. So my chance of winning, guys, will be 1 out of 4. And if you wonder how do I know it's 1 out of 4, this is 1 out of the total. That works in my favor. There is only one event that would work in my favor, one outcome in my favor, divided by the total number of outcomes, which is 4. Okay, we've done this example, but I'm going to write it right here. A probability experiment consists of rolling a die and tossing a coin. Describe the sample space. So we listed them. We had head 1, head 2, head 3, head with a 4, head with a 5, head with the 6, and then tail with the 1, tail with the 2, tail with the 3, tail with the 4, tail with 5, tail with 6. This is the sample space. A simple event is an event that consists of a single outcome. For example, you roll a die, you would win if you get 3. You only have one chance. It's one event. You get the 3 only. That's what we call a simple event. Roll a die, you win if you get a 3. What about, guys, if we roll a die, you win if you get an even number? What's your chance of winning?
2 out of 12?
Let's see. Roll a die. Win if you get an even number. Okay, if you roll a die, what are the outcomes? 1 or 2 or 3 or 4 or 5 or 6. Okay, which ones would work in your favor, guys? The even numbers. So can you help me list the even numbers?
2, 4, 6.
Okay, now, when you want to write the probability, which we're going to give you a definition in a second, look how easy it is. How many values work in your favor? Count them for me.
3.
3. You put it in the numerator. How many values are there all together to begin with?
6.
6. Your chance is 3 out of 6, guys, which is 50%. Yep. So it's 1/2. This is the definition of probability. So I'm just giving you examples before even I put the definition of probability. So your chance is 50-50. You have a 50% chance of winning and 50% chance of losing. Okay. Next one. Before we come to the definition of probability, I'm going to give you this example. You order a pizza. With one topping. In addition to cheese, of course. Okay. You have the following choices. Please pay attention to this. 2 types of crust to choose from. Thin, thick, etc. 3 different types of cheese. But you have to choose only one type. And 8 different toppings. Okay. Please pay attention to this. You want to order a pizza and you want to order one topping. And you have the following choices. How many different choices, guys, do you have? Let's say you want to go in every day and order something different. how many days do you have to go into the pizza place, you know, and order? But you only can order, put one cheese and one topping on your pizza, no more than that.
48.
That is correct. It is 48, and let's explain why. You have two types of crust, so you have two choices here. And then you have three different types of cheese. You have three choices there. And then, guys, you have 8 different toppings. You have 8. We multiply, you know, just those outcomes. We don't add them. You remember when we did let me show you. When we did this, you have 2 choices for the coin and 6 choices for the die. And what we did, we multiplied 2 by 6 to get the 12. And we're gonna do the same thing here, guys. So 2 times 3 is 6, times 8 is 48. And then you have 48. So you guys, you have to go 48 times to the pizza place to order all of their possible combinations that they have, with choosing 1 crust, 1 cheese, and 1 topping. You have 48 choices. I'm gonna take you to this example now. You are purchasing a new car. The possible manufacturers, car size, and colors are listed. You have a choice from 3 manufacturers. You have the car size, 2 choices, and you have the color, 4 choices. In how many different ways, guys, you can select? 1 manufacturer, 1 car size, and 1 color. And since we've done this already, guys, see, I have a chat here. I have a student who says 24, which is correct, because you have 3 choices here. You have 2 choices, and you have 4 choices, and it's going to be 3 times 2 times 4. There are 24 choices. That is correct. The bottom line, guys, is 2 events are happening at the same time. If the first event can happen m times and the second event can happen n times, the 2 events together will happen m times n times, just like the die and the coin. The coin can happen 2 times, head or tail. The die 6 times, together it's 2 times 6. And this is what the theorem is trying to tell you. If one event can occur in n ways, and a second event can occur in n ways, the total number of ways the 2 events occur together is n times n. This is very, very important theorem. It's called fundamental counting principle. I tried to explain it to you guys with an example before even I stated, you know, just a theorem. So this is what we call the fundamental counting principle. Okay? And that was a good example to just define this. Okay, I'm going to give you definition of probability. So this is the first definition of probability, and I'm going to write it down here. It is number of favorable outcomes divided by number of possible outcomes. The numerators, you list the outcomes that you want to work in your favor, and the bottom one is the number of all possible outcomes.
Can you move the sheet up just a little bit?
Sure. There you go. Let's give you an example, guys. You roll a 6-sided die. What's the probability of rolling a 3? Okay, here's how you write it down. You put the letter P. The event, we give it a name, capital letter A, so you can write the probability of A. Okay. If you roll a 6-sided die, guys, what's the chance of getting a 3? How many 3s are there on the die?
1.
1. Out of how many? How How many faces altogether?
6.
Yeah, so the answer is 1 out of 6. Okay, let's go to event B. What's the probability of rolling a 7? Okay, how many faces are there on the die? 6, always. The denominator doesn't change, guys. There are 6 faces. I cannot change that. What's the probability of rolling a 7, guys?
0.
0. There is no thing that would work in your favor here. So if somebody tell you that let's play this game and probably you would win, tell them no. My probability of winning is 0, so I will never win. 0 out of 6 because there is no 7 on the die. C. What is the probability of rolling a number less than 5? Okay, let's see. This is 6, as you can see. It doesn't change, guys. Rolling number less than 5. Let's list them. What would we get? 4, 3, 2, 1. How many? I don't care what the values are, guys. All we care about when we do probabilities to count how many. So I got 1, 2, 3, 4. 4 out of 6.
So when it's saying rolling a number less than 5, so it wouldn't include the 5 itself?
No, that is a good question. No, less than 5, it's telling you exactly less than 5. So you 4, 3, 2, 1. Yes. All right. So it's 4 out of 6. And if you want to reduce this, it's 2 over the 3. That's the probability. So you see, guys, when I told you about fractions to decimals, this is what I meant by that. So probably you will answer this question on the homework and you get 1 over 6. But then the system wants you to convert this to a decimal. So 1 over 6, if you divide 1 by 6. Let's just quit. That's a 1 divided by 6. You're going to get 0.166. Let's say he wants the answer to 3 decimal places. So to 3 decimal places, guys, you need this 6 right here. But since the fourth one is 5 or more, so you need to up that 6 by 1, so your answer will be 0.167. That's how you write the answers. Any questions so far? All right, let's go to the next page. This. That's the next page. And toward the end of this lesson, guys, I will explain to you what are the odds of winning the Powerball, which one in Michigan, just won $1 billion. I think you heard about that. But I'll tell you how do they figure out, the chance of winning, which is very, very low, but someone got it. Okay. I want to look at this example right here, guys. And then I'll go back and write the definition. There's another definition of probability if you have a table. So you have this table. A company is conducting a telephone survey of randomly selected individuals to get their overall impressions of the past decades. So far, 1,504 people have been surveyed. What's the probability that the next person surveyed will have a positive impression of the 2,000? So what's the probability of positive impression? If you have already a table, guys, you see people, you can use it to figure out, to estimate, the probability, the chance. Okay, I told you at the bottom we should have the grand total when we did the classic definition, all possible outcomes. And what's the grand total here, guys? If you add all the responses, how many altogether? 1,504. Okay, good. Okay. The number here in the numerator is the one that works in your favor, if that works in what we want it to do. You wanted the ones who have a positive impression. How many of those have positive impression, guys? Of the 2000 year 406, yeah. And that's your answer. It's 406 divided by 1504. And if you use your calculator to, if he says, let's say you want a decimal to 3 decimal places, no problem. 406 divided by 1504. It's, okay. To 3 decimal places, guys, it will be 0.27. And that will be your answer. Okay, let me ask you another question here. What about if I give you the same question on the test, and I ask you what's the probability that the next person's survey has a negative overall impression of the 2000s? So,
752 divided by 1504.
that is correct. 752 divided by 1504. Okay. So if you have a table, just like the frequency table, guys, right here, there is another definition of probability that we can write here, which is called the empirical definition of probability based on statistics, based on tables. Here, total of all frequencies, or sum of all frequencies, which is 1504, and here, the frequency of the event. So this is another definition. It's just like the classical, guys, but we're using tables right here. All right. So we learned about the classical definition of probability, and then we learned about the statistical definition of probability, which is very much the same formula, but written differently using tables, using frequency tables. And now we have another definition of probability based, guys, on intuition, educated guess, intelligent guess. So the subjective probability, it's called subjective probability based on intuition, educated guess, and estimates. For example, a doctor may feel a patient has a 90% chance of full recovery. How does a doctor, or the surgeon know that the patient is going to have a 90%? It's based on past experience and educated guess, how many times the doctor has performed that kind of surgery. Or when they tell you there's a 95% chance of rain today. This is all subjective probability. It could work, very likely would work, but it is possible that it doesn't work. Or when they tell you there is a 15% chance that you're going to get the flu next year. This is all educated guesses, guys. So if you have any probability that are not based, just on tables or experiment, just like the ones that I show you, we call them subjective probabilities. And here's one example. What I'm going to do, guys, the next example, we're going to do 3 different examples. One is going to be classical, one is going to be statistical probability, and one is going to be subjective, and you're going to help me out and tell me which is which. The probability that you will get the flu this year is 0.1, 10%. What do you think, guys? Is this subjective, empirical, which is statistical, or classical? That should be easy. What do you guys think?
Subjective.
Subjective. How do they know? It's just a guess. This is an intelligent guess, guys. The probability that a voter choosing at random will be younger than 35 years old is 0.3. When we start talking about voters, guys, we're talking about data, collecting data, putting it in tables.
Empirical.
Empirical. Or statistical. Statistical data, you collect data. The probability of winning 100 raffle ticket is 1 out of 100. So you have 100 tickets. One of them is a winning ticket. It's a classical, guys, because there's one ticket that would work in your favor, which is one, and then there are 100 total tickets altogether. So this is the classical definition. All right. Let's say, guys, now somebody asks you to roll, what is the chance of getting ahead when you roll a dime? What would you tell that person? What's the answer? So if you roll a dime, what's the chance of getting ahead face up? Let me see.
F.
50%. Yeah, that's true. Well, let's say this person tells you this. Okay, you think it's 1 out of 2? Let me see. So he rolled the dime first. He gets a tail. He rolled it again. He gets a tail. He rolled for the 3rd time. He gets a tail. He rolled it for the 4th time. He gets a head. Then he gets a tail. And then he starts telling you, I'm not getting the same number of heads and tails that you said it's 50-50. How would you respond to that and convince that person that it is actually a 50%? So you start doing it, guys, and this is what happens. So that person said, you tell the person it's 50% to get that. You get a tail, you get a tail, you get a tail, you get a head, you get a tail, you get a head, and then you get a tail, tail, then a head, etc. And you can see there are more tails than heads. How would you convince that person that it's really 50%? But this person is not convinced because they see more tails than heads. What would you do? Yeah, you said the only 2 outcomes, heads and tails, but how are we going to convince him that this is the case? Because we're doing the experiment and it's not showing that yet. Any ideas? I can convince that person. I can tell that person is not enough to do this one time or 2 times. You need to do it, just many times. Well, he'll tell you, you did it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times. You got 1, 2, 3, 4, 5, 6, 7, 8 heads, 8 tails and 4 heads. That's not convincing. So this is what I would tell the person. Let's do it 100 times. And I'm very much sure that this is going to balance out. You're going to get about 50-50. So guys, when you do an experiment, just 2-3 times and it doesn't give you the results that you want, you just do it as many times as possible in order to see the results. And you cannot just do toss a coin, just once to show that the chance is 50%. Because you're telling someone the chance of getting ahead is 50%. You do it twice and you got tail. That person is not going to believe you. So you just tell the person, let's do it 100 times, let's do it 200 times, 400 times, 1,000 times, and then it will balance out. If you do it 1,000 times, guys, you're going to get close to 500 times heads and close to 500 times tails. It's not going to be exactly 500, but it will be very close. And this is what we call a law of large numbers. As an experiment is repeated over and over, the empirical rule and the classical rule become very much the same. Okay? So this is how would you convince someone who doubts that the probability of landing on a head is 50%. You just do the experiments in front of the person 20, 40, 50, 100 times, and you're going to see, you're going to get about the same number of heads and tails. Actually, I'm going to demonstrate this on the calculator. All right, so let's toss. You see, I got tails. Toss again. I got tails. Let's do it 10 times. Let's do it 50 times. Did you see the balance, guys? So we did it 62 times. Look, they're balancing out. Let's do it another 50 times. another 50 times. And you can see it will balance. It will balance out. Okay, to show you how I went there, you probably have it on your calculator, or probably you don't have it. So you go to apps, right here. So let me just escape and quit, right here. And yes. Okay, here's how you do it. If you have it. If you don't have it, it's okay, guys. So you just go to apps, and then you scroll down to probability simulation of number 9. It's number 9. Enter, and just enter and start tossing. There you go. This is where technology kicks in, guys. See how they balance out? This is how I convince people. Look, 102 times. Let's see how many we got. How many tails? We got 50 and 52, which is very close, 50 and 52. So the chance is 50-50, almost 50-50. This is how you convince people, guys, that do it as many times as possible. All right? Okay, some properties of probability. I think you should agree with me that the probability can never exceed 100%, guys. You cannot say I'm more than 100% sure. So the probability is always between a 0 and 1. I don't expect you to do any homework problem or anything where you guys give me an answer above 1 or below 0. That can't happen. The probability is always between 0 and 1. If the probability is 0, guys, that means the event will not happen. Definitely. If I tell you that the probability that tomorrow is Wednesday, I'll tell you the answer is 0 because tomorrow is not Wednesday. But if the probability is 1, then you can be 100% sure that the event is going to happen. So if you have 10 raffle tickets and one of them is a winning ticket, if you buy all 10 of them, what's the probability that you win? It's 100% because you bought the winning ticket. You bought all of them. So your probability will be 100%. Okay? Any questions, guys? So this is very, very important property of probability. The next one. Let's say, guys, the probability of rain today is 0.3. I want to ask you a question, and I think you can answer it. What's the probability that no rain today? So the probability that it's going to rain today is 0.3. What do you think the probability that there will be no rain today?
0.7.
Very good. Because either rain or not rain, and the probabilities will always add up to 100%, guys. So if it is a 0.3, it's going to rain. It's 0.7, that's not going to rain. And here's the formula. Probability of not E, this is what the E prime, this symbol right there means not E, plus probability of E will always equal to 1, guys. So here's a possible question in the homework, very simple question. The probability that someone is successful in the class is 0.75. What's the probability that he's not or she's not successful? You will do the rest to get the 1, which is 0.25, and so on and so forth. So if you know, guys, the probability of the event, you should be able to tell what's the probability of not the event. The event doesn't happen. So probability of not E plus probability of E should always add up to 1%. The not E in the book, they use this simple E prime. E prime means not E. So if E is rain, not E, no rain. If E is snow, not E is no snow, and so on and so forth. Okay. Next. Let's do this question together. I'll bring the screen. All right, guys. You survey a sample of 1,000 employees at a company and record the age of each. Find the probability of randomly choosing an employee who is not between 25 and 34 years old. All right, guys, how do we do this? Any ideas? I'm listening. What would you do? Of
Add
course,
up all the age, all the frequencies of the people who are not 25 to 34,
and then divide by
and
1,000.
then divide by 1,000.
That's one way to do it. Okay, good. I'm gonna do this. So we want to exclude this. So it's gonna be, as you said, 54 plus 233 plus 180. I agree. That's one way to do it. Plus 125 plus 42. Okay, that would be what, guys? You add them up for me. So let me see. 54. Let me escape. Okay, so we got 54 plus 233 plus 180 plus 125 plus 42. I got 634 divided by 1,000, which is 0.634. That's one way. There's another way to do it, guys, probably faster. Who can tell me how?
366 divided by 1,000.
Okay, well, and then, okay, so you're gonna do 366, so probability of between. Okay, that's another way to do it. Let me show you. Between 25 and 34 is 366 divided by 1,000, which is 0.366. Okay, and what do you do with the 0.366? You subtract it from what? Remember, guys, what I put just a few minutes ago. Probability of E plus probability of not E should always equal to what? To 1. What you did here, you find the probability of people who have age between 25 and 34, which is 0.366, but that's not what he wants. He wants the ones who are not between 25 and 34. So what you can do, guys, you take 1 and subtract 0.366. And you should get this 0.634, which is the same way. So this is using the formula, guys.
The way I did it also was I just like I took the 1,000 and then I just subtracted the whatever frequency was 25 to 34, because sometimes when you have like calculators that don't have like a screen, like if you're just using your phone quickly, you forget sometimes what you add up.
Yeah,
You have to keep going back. So just if you just minus the one frequency, then you
that's
just have
fine. That would work beautifully. Yep, that's good. All right, very good, guys. But look, guys, you do it this way, the longer way, you do it that way, that's fine. You do it just like the student said, also subtract the 366, you get 634 and divide by 1,000, that's fine too. Okay, next example. Your college identification number consists of 6 digits. Each digit can be 0 through 9. First of all, guys, how many college ID numbers we can create, just with 6 digits? So we have 6 digits. How many possible IDs can be generated first from 6 digits, and each digit can be 0 to 9. Let's do this. How many possible digits we can put here? It says 0 is okay.
10.
10. Do you guys understand why she said 10? Because you have a 0 or 1 or 2 or 3 or 4 or 5 or 6 or 7 or 8 or 9. 10. And you guys agree with me that could be a 10 also, 0 to 9. A 10, a 10, a 10, and a 10. All together, guys, we're doing 6 events together. How many all possible outcomes will be there? What do I do with those 6 tens? Never add them. We say we do what?
Multiply.
Just remember, guys, the coin and the dice, we did 6 times 2. The 2 coins, we did 2 times 2. The 2 dice, we did 6 times 6. The pizza thing, we multiply the events. The car manufacturer thing, we multiply the events, and it's the same thing. So, possible outcomes, let me write them down. 10 times 10 times 10 times 10. I know there are some students tempted to add 10 6 times, but don't do that. It's not an addition, it's a multiplication. So the college can generate, guys, 1 million IDs using 6-digit numbers. Now, what's the probability if we have 1 million IDs? What's the probability that I pick one ID and it will turn to be yours, the exact your unique ID with 6 digits? What do you think the chance is? Six here, digits. What's the probability of getting your ID?
1 in a million.
Yep, because your ID is unique. Nobody else will have it. You only have one ID that works in your favor, and no students can claim and tell me I have 2 IDs. Each one of us have one unique ID at the college. Can't have more than one. It's 1 out of a million chance. So you guys, do you think if I have 1 million IDs, if I pull, just pick one ID, it's going to be yours? Likely not, because your chance is very low. If you want to write this as a decimal, guys, look how small this number is. Any questions? All right. Next, I'm going to do another example now with the dice. I have 2 dice, guys. And a red one, and then we'll end discussion with this. So I'm just gonna focus for the next few minutes on the definition of probability. I want you to understand it well. So the Wednesday lesson will go very, very smooth once you understand the definition of probability. It's not a difficult chapter at all. Okay, the outcomes, guys. The 6 outcomes, and we decided that these are the outcomes. I'm gonna list them because I need them. So you just watch me doing this in case if I made a mistake. 2, 1, 2, 2, 2, 3. You get 2 with the 4, you get 2 with the 5, you get 2 with the 6. You get 3 with the 1, 3 with the 2, 3 with the 3, 3 with the 4, 3 with the 5, 3 with the 6. Don't worry, I won't have you list those online. They will be listed for you if you have this question. But for the sake of explaining what we're going to do now, we're going to list them. I'm almost done. And last one, 6-1, 6-2, 6-3, 6-4, 6-5, and 6-6. You guys agree with me that there are 36 outcomes, 6 times 6. Okay, here are the questions now. You roll 2 dice, just like we did. First question, What is the probability of getting a sum of 10 on both faces of the dice? Getting a sum of 10. Let me just do this, move it up, move this so you can see it. So what is the probability, guys, of getting a sum of 10? First of all, can someone tell me what the denominator is going to be? It's the total possible outcomes.
36.
36. We have no control of the denominator. It could be any of them. When you roll 2 dice, guys, there's no guarantee that you're going to get a sum of 10. You could get 1, 1, you could get 1, 2, you could get 1, 3, 1, 4, and so on. You could get any of the 36. Now for the numerator, guys, we're going to count the pairs that would work in your favor and give you a sum of 10. So can you guys tell me the pairs that will give us the sum of 10? Which ones?
4 and 6, 5 and 5.
That's 1. 5 and 5, that's 1. What else? There's one more.
6 and 4.
Yep. For how many?
3.
1, 2, 3. So your chance of winning, guys, if you play this game a sum of 10, is 3 out of 36. That's how you figure it out. I remember I did similar exercise before, and a student said 7 and 3. They add up to 10. I said, yeah, they add up to 10, but they said there is no 7 on the face of the die, so you cannot use the 7. Okay, here's the next question. B. You roll 2 dice. What is the probability of getting a sum of 9? Let's do this together. And again, guys, don't be afraid of putting the denominator. It's going to be 36. Now, sum of 9. Which pairs will give me a sum of 9? 6, 3, 3, 6. Okay, so 3, 6, I heard. And what about 4, 5, guys? That's another one. 5, 4, that's another one. 6, 3, that's another one. So can you see anything else? So it's 4. I mean, do you have to list those? Not really, if you know how to. So if I ask you sum of 9, you start thinking. 3 with 6 will give you 9. 6 with 3 will give you 9. 4 with 5 will give you 9. 5 and 4 will give you 9. So you get 4 of them out of 36, and that would be your answer. Now, some students in the past told me, Mr. Bazzi, isn't 3 and 6 and 6 and 3 are the same? I said, no, and let me tell you why. 6 could show up on the black die, and 3 could show up on the red one. But if you have a 3 here that's shown up now on the black, and the 6 shown up on the red, so they're 2 different colors, 2 different combinations, so they're not the same. 6, 3 and 3, 6 are 2 different outcomes. So you get 4 out of 36. And another example, guys, let me just say this verbally. What's the probability of getting 2 numbers that are exactly the same? What would be the probability? So you would win if you get the 2 faces the same.
I'm sorry, what's the probability of getting them the same or not?
Getting the same faces.
Would it be 6 out of 36?
Yep. And let me tell you why, guys. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. Will be 6 out of 36. You notice, guys, that the probability cannot go beyond 1. It's always between 0 and 1. And this is a good example, guys, of using probability, rolling 2 dice, just and asking questions on that. I guess that would be it.